Integration by parts. U equals x, u dash equals 1, v dash equals sine 2x, and v equals minus 1 over 2 cos 2x. So the integral then, 0 to pi of x sine 2x dx equals uv. So it's minus x over 2 cos 2x integrated or evaluated between 0 and pi minus v du, and du is 1. So what I'm going to do, I can evaluate the square bracket, this bracket here. Subbing in pi, we get minus pi by 2 cos of 2 pi minus 0. Simplifying the integral, minus minus is plus, and I'm going to take out 1/2. So what I have then is the integral of from 0 to pi of cos 2x dx. We have minus pi by 2, cos of 2 pi is 1, plus 1/2. When we integrate cos, we get sine, so it's 1 over 2 sine 2x and it so happens that, well, what we have here is sine 2x. When x is pi we have 0, and when x is 0 we also have 0, so the final answer is minus pi by 2. So what we're going to do is to replace x with minus x and see what happens. So we have minus x to the power of 3 and then cos of minus x. Now it's useful to know that sine of minus x equals minus sine of x, and that sine is an odd function. Cos of minus x equals cos of x, and cos is an even function. Now, minus x all cubed is minus x cubed. Cos of minus x is the same as cos of x, so what we have here is minus f of x, and in that case the function is odd. So implicit differentiation is how we'll proceed with this. 2x cubed, when we differentiate it with respect to x, gives us 6x squared. Now we come to the product here, so I'm going to differentiate the first, that gives me 6x, and I'll leave the second, I'll leave the first, and then differentiate the second, so that's 3y squared dy by dx. And the plus 4 at the end is a constant and becomes 0. So I want to get dy by dx on its own. It's 6x squared minus 6xy cubed, and dividing by this part here, which is 9x squared. What I want to do next is to stub in the point 2, 1. So dy by dx then is 6 times 2 squared minus 6 times 2 times 1 cubed. And we've got 9 times 2 squared times 1 squared. 2 squared is 4 times 6 is 24 minus 12. 2 squared is 4 times 9 is 36. So we then have 12 over 36, which is 1 over 3. That's the gradient of the tangent. So we have m equals 1/3. And we have the point 2, 1. So to work out the equation of the tangent, it's y minus 1 equals 1/3 x minus 2. We'll multiply by 3, and that's 3y minus 3 equals x minus 2. Find the general solution of the differential equation. What we can do here is separate the variables. So I'm going to write that as dy, and I'm also going to factorise that term. So we take out y as a common factor, and it's 1 minus y equals dx over x squared. Now the right hand side is not a problem. The left-hand side requires partial fractions, so 1 over y, 1 minus y, equals a over y plus b over 1 minus y. 1 equals a lots of 1 minus y plus by. Now when y is 0, and when y is 1, that was nice and simple. So we can then write this as 1 over y plus 1 over 1 minus y. And the integral becomes, so we've got 1 over y plus 1 over 1 minus y integrated with respect to y, and that equals x to the power of minus 2 integrated with respect to x. So it's natural log of the modulus of y minus natural log of the modulus of 1 minus y equals x to the minus 1 minus x to the minus 1 plus a constant of integration c. Now we've still got quite a lot of work to do with this. What we can do is, so that's the left hand side. This is minus 1 over x plus c. Now remember, this is log to the base e. So I'm going to convert from log form to exponential form, which means that y over 1 minus y equals e to the power of minus 1 over x plus c. I'm going to multiply by 1 minus y and y equals, so it's e to the minus 1 over x plus c minus y e to the minus 1 over x plus c. If I move both of the y terms together, I get y plus y e to the minus 1 over x plus c equals e to the minus 1 over x plus c. Take y out as a common factor. And I have then divide. Now, almost there, consider this term can be written as And this part, E is a constant and C is a constant. So what we're going to do, just to simplify this, is write that as A, some constant A. And a similar simplification will take place on the bottom line. The volume formed by the solid of revolution is given by the formula pi, and it's the integral from 1 to 3 of y squared dx. And that gives us x squared over 3 plus 1 all squared dx. So that's x to the 4 over 9 plus 2x squared over 3 plus 1. And when we integrate, x to the 5 over 49 plus 2x cubed over 9 plus x. So subbing in the values given, we get 243 over 45 plus 6 plus 3 1 over 45 plus 2 over 9 and that's 592 pi over 45. The first thing to do is to prove true for n equals 1. So the left hand side, sigma r equals 1 to 1 of 1 over 3r minus 2, 3r plus 1. Replacing r then with 1 is 1 over 3 take away 2 and 3 plus 1. That's 1 over 4. The right hand side, when n has the value 1, we've got 1 over 4. So it's true for n equals 1. We want to assume it's true for n equals k. So sigma r equals 1 to k of 1 over, and that's 3r minus 2, 3r plus 1 equals k over 3k plus 1. And the last thing we want to do is to consider the case when n equals k plus 1. So when r equals k plus 1, what we're going to do is to replace r with k plus 1 in both of these brackets. So I get the fraction 1 over 3k plus 1 minus 2, 3k plus 1 plus 1. Now, what happens next? We don't really have enough space, but what I'm going to do is replace this whole term here with this here. And that gives us, so it's k over 3k plus 1. Now simplifying the brackets, that gives us, so it's 3k plus 3 minus 2, which is 3k plus 1. And 3 times k plus 1 is 3k plus 4. Now I want to combine these two terms. What I can do is take out 1 over 3k plus 1 as a common factor. Hope you can see that. And that leaves me with k plus 1 over 3k plus 4. So what I'm going to do then is I'm going to write this as k times 3k plus 4 plus 1 over 3k plus 4. Now just put a bracket around all of this. Oh, bracket around this top line. I can now take out, well, let me just simplify the top line. So it's 3k squared plus 4k plus 1. And on the bottom line I have 3k plus 1, 3k plus 4. The top line can factorise. That will give us 3k and k, and 1 and 1 and plus and plus. These two brackets cancel. So it's k plus 1. Now what I'm going to do with the bottom is write it as 3 lots of k plus 1 plus 1. And that's exactly what we wanted. Now what you have to do is to add in the conclusion. So we're told that the radius is increasing at the rate of 0.2 centimeters per second. So the radius, or dr by dt, equals 0.2 centimeters per second. Calculate the rate at which the area is increasing at that time. What we want to do is to work out dA by dt. Now what is it that links these two? It's, well, we know that the oil is forming a circular stain, and what we really want then to link these two is dA by dr. Well, if the area is a circle, then area is pi r squared, and differentiating area with respect to r gives us 2 pi r. Now it then says when the radius of the stain is 3 centimeters. So when r equals 3 centimeters, we've got dA by dr 2 times 3, and that's 6 pi. So let's put these things together. dA by dt, which is what we're trying to find, equals dA by dr times dr by dt. dA by dr is 6 pi, dr by dt is 0.2, so we have 1.2 pi, and it's going to be centimetres squared per second. So, first thing we can do is find dx by dt. Well, that's going to be 3 cos t. So dx then is 3 cos t dt. Two x minus 1, the top line, is 2 lots of 3 sine t minus 1, which is 6 sine t minus 1. I can look at the bottom line as well. So the root of 9 minus x squared equals root 9 minus, well, that's 3 sine t all squared, which is the square root of 9 minus 9 sine squared t, and that's the root of 9 bracket 1 minus sine squared t. And what we can do with that is write it as root 9, which is 3, and the square root of 1, well, that's 1 minus sine squared is cos squared, so that gives us 3 cos t. So the integral becomes, it was 2x minus 1, so that was 6 sine t minus 1 on top, and it's 3 cos t on the bottom, and dx is 3 cos t. So we have top and bottom cancelling like so, and we've just got the integral 6 sine t minus 1 integrated with respect to t. That gives us minus 6 cos t minus t plus c. Now, we know that x equals 3 sine t, that was the original substitution. Sine t is x over 3, and t then is sine to the minus 1 x over 3, and that accounts for the second term, this term here. So it's minus sine to the minus 1 of x over 3 plus c. But what about the minus 6 cos t, the first term? Well, cos t is the root of 1 minus sine squared t, so that's the root of 1 minus x squared over 9, which is 9 minus x squared over 9, and that is square root of 9 minus x squared on top and 3 on the bottom. So we've got minus 6 lots of square root of 9 minus x squared over 3, and that gives us minus 2. That's 9 minus x squared minus sine to the minus 1 of x over 3 plus c.